A stamp 2 centimeters tall is being held 7 centimeters from a lens that has a focal length of negative 5.5 centimeters. That is, it's a diverging lens. Where is the image located? What kind of image is it? Is it right side up or upside down? And how tall is it? We'll solve this problem by drawing a ray tracing diagram and by calculation. And as always in these ray tracing diagrams, we're going to start off by drawing a principal axis. There we go, thick red line, and the plane of the center of the lens. We're going to set up a scale. 1 block is equal to half a centimeter. That puts the focal point here. And here. Whether the focal length is positive or negative, you still count off that distance on either side to mark your focal points. And then we're going to have an object that is 2 centimeters tall, or 4 blocks. Right there, 1.5 centimeters beyond the focal point. So here we are, and we need to draw our principal rays then. Oops. Here's our parallel focus ray. Our central ray. And my parallel focus ray I messed up on. This is a diverging lens, so the ray is going to bend away from the axis, and so that it appears to be coming from this focal point. So we're going to draw the ray like this. Now what I'm going to do is I'm going to draw another line just right on top of that, and then get rid of this. So there is our parallel focus ray, appearing to come from here, diverging away from the axis of the lens. The central ray, by the way, is always easy to draw, just straight through the center of the lens. Lastly, we need to draw our focus parallel ray. So we're going to draw a line towards this focal point here, and then that is going to diverge away from the axis and become parallel. And again, I'm going to do this little trick where I'm going to draw another line on top of the first one to this point, so that then I can get rid of that. So there are our 3 rays passing through the diverging lens. And now what I'm going to do is to trace those rays backwards. They are diverging. We are not going to get a real image to the right of the lens. The rays are not coming together. So we're going to trace back, and I'm going to use a thin green line. I'm going to trace back a straight line parallel to all these others and see where they cross. And we don't need to trace back the central ray because it never bent. So our image is located right there. And that is 1 centimeter, 2 centimeters, 3 centimeters. I'm going to call that about 3.2 centimeters to the left of the lens. And the height of that image looks to me like about 0.8 centimeters or 8 millimeters. It is a virtual image, and it is right side up. Okay, so that is that problem using a ray tracing diagram, part A. Now let's go ahead and calculate the results using the thin lens equation. So we have 1 over f is equal to 1 over do plus 1 over di. So 1 over di is equal to 1 over f minus 1 over do. So we have 1 over negative 5.5. Our focal length is negative 5.5 centimeters. Minus 1 over 7.0 centimeters. So we've got negative 5.5 negative 1 over minus 7 inverse equals, and remember that's 1 over di, so we want to take the inverse of that, and we get 3.1 centimeters. So di is equal to negative 3.1 centimeters. The magnification is negative di over do. So we have negative of negative 3.1 over 7. 3.1 divided by 7 gives us 0.44. So in other words, the image is 44% the size of the object. And therefore, the height of the image is the magnification times the height of the object, 0.44 times 2 centimeters, and that is going to give us 0.88 centimeters.